Okay, now let's examine moments. Okay, now we go back to the door example again. Okay, so let's assume the first part. We say that the moment to open the door, the amount of moments we need to open the door is 100 Newton meter. Okay, let's just say this is the amount of moments that we need. So, if given that the door is 1 meter wide, okay, we assume that if the doorknob is placed at the furthest end, the perpendicular distance is 1 meter. So what they're trying to say is, if you have a door, the doorknob is here, the hinge is here, okay, hinge, this distance here will be 1 meter. Okay, so this is actually your perpendicular distance. So now, so if we say that, if we use that the moment of a force that we need is 100 Newton meter and the perpendicular distance is 1, so let's have F. Okay, we must calculate what's the force needed to open the door. So if you do some simple maths, bring in the 1 over, you realize the force needed is 100 newtons. So therefore, the force needed is 100 Newton when the doorknob is 1 meter away from the hinge. Okay, when the doorknob is 1 meter away from the hinge, the perpendicular distance is, in this case, 1 meter. Now, what if, let's just say some silly engineer puts the doorknob very near to the hinge. Okay, so if it is placed near the hinge, let's just say 0.2 meters away. So imagine a door. This is where the hinge is. Okay, hinge. And the doorknob is placed here. So the distance here is 0.2 meters. Okay, so this is a very silly engineer that we have here. So by using the same formula, let's just say to open the door, we need to use 100 Newton meter. So you can see here, it is still 100 Newton meter because the moment needed is still 100. Okay, but now, we want to find out what's the force needed. And we know now the doorknob is placed 0.2 meters away from the hinge. So the perpendicular distance is 0.2. So therefore, F equals to 100 divided by 0.2. We need to exert a force of 500 Newton. You can imagine here, previously we only need 100 Newton. Okay, if the doorknob is placed 1 meter away, somewhere around here. But once we change the doorknob to here, 0.2 meters away, the amount of force we need is almost 5 times. It's exactly 5 times. 500 newtons. So the force required is way too much. So therefore it is silly, okay, to put a door hinge, to put a doorknob near the hinge. In this case, worst case, 0.2 meters. We tend to place it very far away. Okay, so what can we conclude from this? Okay, there's two things here. The further away the force is from the pivot, okay, we need to use lesser force to produce the same moment. In this case, lesser force to produce the same moment. The next statement is also with regards to what we have done just now. Another way we can put it is, the further away the force is from the pivot, in this case we say that it is the larger the moment produced. Okay, so we can produce a very large moment if the force is very far away from the pivot, or we can say that to produce the same amount of moment, lesser force is required. So just these two statements is just a different way of phrasing. Okay, one is we focus on the same moment, the other one we talk about is the large same force but larger moments. Right? The larger is the moment produced with the same force. With a same force. Okay? So it depends what is the constant here. In this case, the constant here is the same moment. For the second statement here, we are focusing on the same force. So it's the different constant that we are comparing. Okay, now, so this is the way how we go about using the calculation to explain certain phenomena in our life. Okay, so this is the end of part